Yeah, hi, welcome back. Rashid here. And we are in week 6 of STA from scratch training. Yes, we are halfway there. And sorry, last week and a half, I've been releasing video almost every day, one video for the members only. And we are getting into the practical things. And I'm really enjoying it. I'm really heads down into this training right now. Okay, just a reminder. The cost of the this training is, I think, pretty reasonable. If you are in US, it's $2.99. If you are in India, for example, it's 89 Indian rupees per month. Okay, so today what I'm going to do is in this video, which is going to be for everybody, I'm going to review what I did in the last week and a half. So, and during that time, it was all focused on the practical demo, and I didn't get chance to explain the theory. So I will try to revise things what I did. So I think that would be good for the people who are doing this training, and I will dig a little bit deeper into IO constraints, and conceptually I will try to explain things. Even though I had some previous videos there in a different playlist, but I'm gonna do that again here. Okay, and what we are doing is we are taking a simple SOC. Um, it's an educational project, but it has everything in it. Um, and this SOC, we are developing tape out flows. So from scratch, doing everything, checking logs, checking every thing that is critical at every stage. And this is what we have done so far. So right now I'm focusing on a single mode, single corner. Later on, I will add more scenarios or more views into it. So STA flow is very simple. Okay, there are some key stages in it. For example, if you look here, first we do a linking. So we read in the netlist and we read in timing libraries. So timing libraries will be from the standard cells as well as from macros in the design that I've just started. That has SRAM, that has ROM in it, and it has pads in it. So it has everything that you will have eventually, almost everything in a design. So very first step is linking it. Linking means that whatever you have in the netlist, somewhere either in netlist, if it's an hierarchical module, or if it's a standard cell or a macro or a pad, it has a definition in the libraries. So linking process kind of links everything together. What we did was, when we finished linking, we reviewed the log file in detail. And that is very important. You cannot miss critical warnings. You cannot definitely miss errors. And it also helpful if you go through the information messages so that you learn what the tool was doing. So as you have seen that in one of the videos, I have gone through everything in the linking log in the read netlist log file. And we also created a custom tickle code. For example, instead of going to the log file and figuring out if something is not linked, or in other words, we can say not map, or we can say is black box, right? We also created a tickle code that I think I'll show you later on. A very simple thing. Actually, we did look into a lot of tickle stuff, and I showed you some properties, attributes, and some filter collection. So using that, we create a very simple procedure which we run and which throws out stats of the cells in the design, as well as it will tell us if there are any unmapped design. So while we were there, I even modified a netlist, get an updated netlist to resolve some of the linking problems. And among other people, if they are not able to find the lib, they need to go and give the flow right set of libraries. So once that is clean, then what we did initially, we didn't create any constraints. So we started with just run check timing. What kind of messages, warnings, or errors it throws out. And then one by one, we resolve all the problems in check timing. and gradually built our constraints tickle file. So we created actual clocks, we created virtual clocks, we gave input delays, output delays. There were some application variables we set to ensure that we don't see constant propagation. And then we set driving cell. I mean, all those kind of things we set over here. And eventually we got check timing clean. So once we got that clean, then we read in spec file, wires, resistance, and capacitance information that comes. So originally a routed database that we use to generate very long netlist, but a routed database was also used to extract resistance and capacitance for wires, so parasitic file. So that parasitic file is saved in this format, spec file. We even looked at a spec format, just picked a net and look at an example. How it is name mapping section, connectivity section, resistance, capacitance, and all that. And then when we read that, we redirected the output of reading spec into a log file. Went through the log file, look into everything, thoroughly analyze it to ensure that we understand the information messages, warnings, and errors. And as a result of some of those things, now I didn't fix everything along the way, but some of the things I put, if you've seen, in a to-do list. So later on, I will get to those ones. So I'm not blocking myself here. I'm keep moving, keep making progress. But some of those lower priority things, which are not gonna impact my design or analysis later on too much, I just left those. The IO constraints we created were also very simple initially, and we said, okay, we're gonna start analyzing things. So now next stage, which is this week 6 as well as week 7, we will look into every port of the design, and we will look into timing of every flop in our design. Hold timing and setup timing. We will do that, and based on that, we might update some of the constraints file as well. So that's the activity that we're going to do in the next 2 weeks. All right, flow, as you see that, okay, I put in flow as STA as a simple flow, read underscore layers. We can read some files, we can timing libraries, we can read netlist, source constraints file, check timing, and spec file. All right, so let's start gradually in the same sequence I created videos. So we have netlist, and then actually let's start here. I don't plan to do that. I have a little bit more stuff on IO constraints, but let's go there first. So we read in the netlist and we review the log file. In the log file, okay, we have looked at several information messages. We saw that, okay, there is some default views are created under the hood. Then we look at some of the critical warnings that we had in the design. We had a physical only cells whose function attribute was missing, and that was okay. We didn't need that. And then we had few other messages like lib is defined. We had duplicate definition in the netlist as well as we were reading the timing library. So we had some of those problems. So timing library missing VSS VDD pins. So look like when we were instantiating some of the cells, they had VSS and VDD pins as well. So we definitely had some net listing issues when we generated netlist out of implementation tool. We need to go back and we need to improve our netlist generation mechanism for the timing, because for timing we just need a logical information. We don't need power pins. Those we also create a to-do list that we will create a UPF file later on so that we'll understand that which ones are power pins or power nets. All right, and we have seen that, okay, after certain messages, when we get a lot of warnings, after maybe 20 messages by default, tool just stops, it doesn't throw more so that it doesn't trash the whole log file. All right. Then linking, once we did the linking, we noticed that, okay, we don't have to go every time back to the log file. So we created a lot of procedures actually. I created a gen tickle procs file, and for displaying things, for getting some of the nets, pins, and for different commands, I created simple procedures. But one of the procedure was that you call that procedure after linking, and it gives you some cell statistics, as well as it also gives us a list of the unmapped cells. So in our final design, we don't have any unmapped design. We made use of filter collection, get cells, regular expressions, and how we can call some properties or attributes and how we can check them, and how we can actually even call some particular instances in our design. So we will look a lot more into this as we look into reporting. All right, so after linking was good, next thing was check timing. And that's where we come into clock definitions and IO constraints, which is where I'm going to spend some time. Okay, so check timing, without creating any clock definitions, we ran check timing. And as you expect, it gave us about 3,000 clock pins which are not clocked, which were as expected. So at least we knew that, okay, there are 3,000 sequential pins or end clock pins. Okay. So we ran check timing, and a check timing throws a lot of warnings and gives you the count for each. It doesn't give you detail without using verbose command. So when you want to use verbose, for example, 3,000, you want to list all of those, you can mention dash check only and only give the text that came in the default check timing, which was pointing to unclocked cells. You put that text and then you dash verbose, and you can redirect that into a report, which we did. And we open that and we look at those ones. Some of those we analyzed with all fan in command. Yeah, we use all fan in and all fan out a lot to go back. So without knowing any specs from any RTL description, we figured out, okay, where the clock was missing. We did all fan in, and on different flops, when we did all fan in to the clock pin, it came back to this pad. Okay, so we created a clock definition on the pad. This is the SOC that we have. These are the pads, and inside the design we had even pads there. So in this case, this clock is coming from outside world, and we knew the frequency. We set 100 megahertz here. So this is the command we use. Is a standard clock definition STC command that we use. We also had a JTAG clock that we figured out, and we defined JTAG clock here. We haven't defined any asynchronous relationship between these two because they are coming from a different PLLs. So that means they should not have timing path between them. I mean, their edges will not be aligned. Okay, so you can not ensure that. But right now we have not put any exception like false path or MCP there. So eventually it was pretty simple for us just with these couple of definitions, mainly this one because our design at that time didn't have a good JTAG connectivity. Just using this one, we were able to get check timing clean for only unclocked. Okay, then we ran check timing again, and now we were seeing messages unconstrained endpoints, no input delay, no driving. So we had a ton of unconstrained endpoints. And I mean, even though we created clock definition and most of the endpoints should be gone because they are getting clock definitions. And I was really expecting the output ports will be among some of the major one unconstrained. But we figured out when we did this report, we did a verbose on that. And we did all fan into some of those to see where those clock pins are coming back to. And we figured out a lot of stuff was dangling, not connected, or actually the constants were propagating. So they were tool tie off, input of a flop was tied off, and then constants were propagating. And we found a variable in the tool that when we set that, the report of pure unconstrained endpoints and the report with constants was separate. So that was easy for us as we don't have to spend time on the constants. And then we also have dash no driving. So these are mainly because our ports are not constrained. So an obvious step after you define your clock definition, ensuring all your registers are getting clocks, the next step is that you constrain your inputs and output ports. Okay, so here I want to give you some background on it. All right, I'm thinking I should maybe do it in the next video or this video. All right. Yeah, let's finish it here. Otherwise, it will be too long, and I'll cover the IO constraints part in proper detail in the next video. All right. See you next time. Bye.